Welcome to this video tutorial on how to analyze single-cell datasets using ScarfWeb. My name is Göran Karlsson. I'm the co-founder and head of partnerships for Nigen Analytics. When you've logged in to ScarfWeb, you end up on the project page. Here, select the dataset you want to analyze. To start the analysis, click the Analyze button. Now on the Analyze page, you will see the 3 steps for analysis setup. The first step is filter out poor quality cells. In this step, you will notice 4 violin plots on the right side. Transcripts per cell represent the total sum of all the observed reads or UMIs for each cell. You can use the handle below the plots to change the parameters and include or exclude cells. Here I remove the cells that are outliers on the higher side of the distribution. Also, if you notice a secondary bulge on the lower side of the violin plot, then that could indicate low quality cells or non-cell barcodes that should be filtered out. Having less than 500 transcripts in a cell can make the data very sensitive to noise. You should also avoid having more than a 20-fold difference between the lower and the higher threshold. Genes per cell summarizes the total number of detected genes per cell. A gene is considered detected if there is at least one read or UMI attributed to that gene in a given cell. This is an essential quality control metric, but it varies a lot depending on the underlying single-cell library prep method used. Having less than 200 transcripts in a cell can make the data very sensitive to noise, and you risk including non-cell barcodes into the analysis. Having a large difference in the upper and lower threshold values here can have an even more dramatic effect than for transcripts per cell. Mitochondrial and ribosomal counts shows the percentage of all the reads from a cell that originate from mitochondrial or ribosomal genes. A high percentage can be indicative of poor quality cell capture. Importantly, for all these parameters there might of course be biological reasons for including or excluding cells, and this is why analysis for ScarfWeb is highly customizable. If you're running a reanalysis or have merged together samples, then you may have certain categorical metadata available in the Group Cells By option, below the violin plot for each of the filtering categories. This could be, for example, cell cycle data, source data, or HTO labels. You can also see how many cells are included in analysis depending on your parameter settings. Next, we choose the highly variable genes, which are the genes that vary across the dataset and will be used to establish the heterogeneity. The corrected variance corresponds to the differential expression. You can hover over the dots to see which genes they represent. Using more highly variable genes increases heterogeneity, but could also introduce noise. The normal number here is 500 to 2000, while having less than 200 will make the data too sensitive to which genes are selected. Play around to see if you get the data you expect. You want to find clusters that have strong differential gene signatures. Minimum number of cells per gene should be approximately the same as the minimum number of cells in the smallest cluster you expect. For example, if you expect your smallest cluster to be 100 cells, you should select this number to be 50 to 70. If you select a higher number, you might lose that cluster identification. If you pick a too low number, you get genes that are of low abundance and with random expression that will give noisy data. In this list below, ScarfWeb removes genes that is not recommended to be included in the highly variable gene selection by default. These include cell cycle genes, HLA genes, and others that risk forming biologically irrelevant clusters. You can remove gene categories from the default block list if you want to include them. You can also block individual genes yourself if that is important for your particular experiment. Remember, excluding genes in this step only means that you exclude them from UMAP or tSNE formation. All genes will still be available to explore in your downstream analysis. The highly variable genes will be used to run PCA on your data, and we select now how many PCA dimensions we use. A high number here will create noise, and less is loss of heterogeneity. First, try the default setting of 15 and test by decreasing or increasing with 5. You look for a number where changing plus minus 5 doesn't make much difference to your results. We next try to find which cells are most similar to each other. The default value for KNNs of 11 means that we try to find the 11 cells that are most closely related and form a graph with these. To choose this number, consider the probable size of your smallest cluster. If this is, let's say, 20 cells, and you have a KNN of 30, you will get false neighbors. Pick a KNN that is lower than your smallest cluster cell number. A value of at least 10 is usually good. In very large-scale experiments, the cells are often sparse in depth, and then you need a higher number, like 2021, to get true clusters. Finally, you set the resolution parameters that are centered around 1. Here a high number gives you many clusters, while a low number creates few clusters. This number reflects the ratio of connection the cluster make within against across clusters. When you have set your parameters, click Start Analysis. You will then come back to the project page and the analysis will run for a few minutes. When the analysis is done, you can click View and you will come to the Explore Data page. Here you can go to Cell Metadata, where you find a lot of useful features to evaluate your analysis. You can, for example, visualize how different resolution parameters can affect your clustering. Also, you can visualize transcripts per cells, genes per cell, and ribosomal or mitochondrial counts to see if you have technical clusters that might prompt for reanalysis. Looking at cell cycle status in your UMAP could also be useful. If you feel the need to reanalyze your dataset, just go back to the project page and select Reanalyze, and you will be able to do so. With ScarfWeb, you can reanalyze as many times as you like. For each analysis, all parameters are stored here for documentation and reproducibility. You're now ready to explore your data and create figures for your presentation or your manuscript. Please check out our other video tutorials for support on how to do the best analysis for your experiment. Thanks for watching this tutorial. Don't hesitate to reach out to me on goran.karlsson@nigen.io or check out our webpage nigen.io. Good luck with your single cell analysis.